I'm going to be talking about the top 20 design tips for enterprise data architects today. There's a basis for the rationale behind the presentation. As a former senior consultant at MySQL, I was charged with going out to client sites every week, and a lot of problems which involved, oh, please fix our performance problems, but you can't change the schema, or you can't change the code, just tweak something. 95% of performance problems inherently come back to design. So I sort of constructed 20 tips for enterprise data architects based on experience where I've never seen a client do all 20. So hopefully there's some input for everybody. So, not messing around. Tip number 1, you need to know your technology tools. The reason why I say this is that I could go into a client site and I can say, oh, you have an Oracle data architect, or you have SQL Server developers, or you don't have a data architect, full stop, because each type of person leaves certain traits based on their experiences and knowledge. So the important thing here is that you've chosen MySQL as a product in your development. So potentially here, maybe you haven't chosen MySQL, but on the assumption for your project, you've chosen MySQL as a database product. What you need to do is you need to maximize its strengths and minimize its weaknesses. To do that, you need to know about the tool itself. You can't become an expert from day one from an Oracle background and automatically become a MySQL DBA. Paul Tuckfield is a great example from YouTube where you can talk about when he first came there, what he had to learn to upgrade to MySQL. So one of the things that's important that when you decide to do this, learn and understand your tools. There's nothing rocket science in anything I'm going to say today. They're all basic tips, but they all combine together. They just make you think about, are we doing these in our environment? That was easy. Seems like I had the overview slide in the wrong place. That's the proofreader's problem, not mine. Just to expand a little bit on knowing the product strengths and the product weaknesses, some pointers that you should think about with MySQL, as listed up there, is what are the options for scale out and high availability? Which options exist? What's best for your environment? MySQL has several different offerings. And other service providers here, as shown in the exhibit hall, have different offerings as well. A key differentiator with MySQL from non-MySQL databases is the principle of storage engines. It's very important that you understand that that principle does exist and that you look at the differences between storage engines. And unfortunately, I can't give you a chart of the 15 plus storage engines that exist and what the pros and cons are of each, because that's something that no one seems to have. One of the strengths of MySQL is that it has a query cache. You need to ensure that caching exists in your application at multiple levels. You've heard this week about memcache in quite a lot of detail. MySQL has its own version of query cache, and it can either help you or hurt you depending on your application. So it's very important that you do be aware that it's there, and it may be of benefit. People try to use a query cache, for example, and they don't realise that using a non-deterministic function negates the possibility of the query cache. MySQL also has a number of weaknesses in its present GA release. No online alter. These, again, there's nothing new here, these things that exist. So the inability to be able to have your database online 24/7, Web 2.0 or e-commerce site, and the limitation of not being able to change things when you don't allow downtime is important. So what scale options do you use? Backup strategies. As the resident technical speaker at MySQL previously, talking to Oracle DBAs, when I would come to the particular point, I would say MySQL has no one single unbreakable backup solution. And this is a limitation that exists, and so there are very creative ways of working around that. And then there are various things that affect your backup solution. For example, the points in the maximising the strengths, the different scale out options, the different storage engines. The other thing that I find is the greatest weakness as going in and solving the problems of people's websites is instrumentation. When you're charged with doing performance analysis on a system, and you're there for 3 days and they want their answers right now, the first thing is you want to be able to pull the information out about what's going on. And so that is a present weakness. MySQL proxy is something that I've advocated for since I found out about proxy at this conference last year. I was one of the first consultants to actually use it on site at a large client, and it enabled a better level of instrumentation, and that can help you. Other than that, you need to learn out what to look for, what to monitor, and look for what you can actually do to tune your system. We'll talk about that a little bit more. This is the number one thing that I do when I go in onto a client site. There's nothing complicated about it. It's trivial, but no one seems to do it very well. And I put it down in 3 simple words. Disk equals memory equals performance. I should say, for all those very ambitious typers out there, the slides are available on my blog, so they'll be available after the talk. So disk equals memory equals performance. What does that mean? Back in the old days when every byte used to count, that's still relevant today. As I list there, on most engagements that I attended, I would get a saving of around 25% on the disk footprint alone. So without even talking about the physical implications of that, just the mere understanding that of the 4 types of the processor, the CPU, the network, the disk. You know, if you can decrease your disk footprint, then you're losing less disk I/O, and it's the slowest access to data. Having a better system, seeing a 60 gigabyte performance and 60% improvement in disk footprint. So I reduced the disk footprint by 60%. And if you've been going to one of the other scaling sessions, you would have actually heard from that client that particular point. So when the system was 200 gigabytes and now 60% less, just all the logistics, backups, the time it takes to read data decreased. And the best that I've done on the site is 78% across the entire schema. It's not rocket science, so I'll give you a few tips on what you can do there. The first is you need to know your numeric data type. And also, coming from an Oracle background, having worked at Oracle Corporation, and knowing the things that Oracle DBAs and architects do, MySQL has 9 different numeric data types. You need to learn those data types and maximize them for your environment. In comparison, Oracle puts all of those into one. It supports integer, floating point, and fixed point, all within the number data type. Where in MySQL, you can see on the screen there, various different data types for integer, fixed point, floating point. And also, there's a bit data type, and we could also potentially, I say maybe, enumeration is a form of actually storing a set of fixed values, which will be recorded into a tiny int column. So you need to learn these specifically. Here are some of my favorites that I see. int1 is wonderful. I've actually got another slide on that. Seeing big int, auto increment, seeing columns where no unsigned is used, a typical Oracle oversight. And the best one I've seen is decimal 31,0. I just need to check whether there's a slide on decimal 31,0, otherwise I'll tell you exactly why it's so bad. So int1. Hands up in the room who thought 1 stood for the number of bytes that are stored in an integer column. The people that are too embarrassed. Oh no, we've got a couple of takers, that's great. I'm glad you're here. Hopefully you'll learn something. 1 does not represent 1 byte. Okay, int is a 4-byte data type, and 1 just simply means how it's going to be displayed in the MySQL client output. And it doesn't really solve any problems because you can still put in larger values anyway. And so, yeah, as I said there, int's 4 bytes, tiny int is 1 byte. So if you have a lot of columns, like 5 or 6 columns, which are like int1 columns for flags, and then say, for example, you have an index on those 4 flags, not only are they like 20 bytes that can be condensed down to 4 bytes, but your index is also condensed down in size. A tiny int can store values from 0 to 255. So depending on what your data needs are, that may be all that you actually need.